Hello and welcome to this presentation about our denominated degree program MH206, Theoretical Physics and Mathematics. This is a double major. In other words, it's a joint program between the Department of Theoretical Physics and the Department of Mathematics. And in this presentation, I'll talk mainly about the theoretical physics side. What I want to do in this talk is basically just go through a few things about the content of the degree, a little bit about its structure, and then a few things about what you might do with a degree in this subject, and also some of the background. So let's crack on. When I give this talk in person, I usually ask the audience if they can name a famous physicist. So if I ask you that now, think of what names you would come up with. Now, I don't know what names you've picked here, but one of the things that I've noticed is that whenever I ask this in a live lecture, the sort of names that come up are names like Stephen Hawking, Albert Einstein, Newton, Isaac Newton, maybe Maxwell, maybe Dirac, Schrödinger. A few other names come up. The notable thing about those is that the physicists that most people can name are theoretical physicists. All of those names that I've mentioned are the names of theoreticians, not experimentalists. Some of you may also have named this person. If you didn't, this is Peter Higgs, the man who thought of the idea of the Higgs boson, which was discovered at the Large Hadron Collider in CERN a few years ago, and led to Peter Higgs getting the Nobel Prize. And you'll notice that he was actually giving a lecture at Maynooth when this photograph was taken. He's a friend of the department, and actually we do research, members of the department do research in particle physics, which is his domain. So what is theoretical physics? Well, you can contrast it with experimental physics, which is another department here in Maynooth University. Experimentalists obviously design equipment, they make measurements, they discover patterns in the behavior of different kinds of systems. And that's what experimentalists do. What theorists do is to try and explain those patterns, those regularities, in terms of mathematical laws. So we don't do the laboratory work. There are no laboratories in theoretical physics. But what we do is mathematical work. And it starts off a little bit like the Leaving Certificate Applied Maths. Although you're not required to have done applied maths to start this program. We start from scratch. But if you want to see a little bit of what the content is, you might look at some of the materials about that Leaving Certificate Applied Maths. Now, as well as finding out and trying to explain why observations and experiments give the results they do, we can also do other things like making predictions of what other experiments might do if they were that haven't been performed yet, and also what things might look like in a universe where the laws of physics were slightly different. That's a lot of fun to do that as a sort of speculative kind of physics. So on the right of this slide, you can see a list of the topics that theoretical physicists would study: quantum physics, various kinds of quantum physics, quantum technology, quantum computing. There's also particle physics, as I mentioned before, gravitation and cosmology, that's my own area of research, climate physics, meteorology, fluid dynamics, chaos theory, financial modeling, solid state physics, superconductivity, all kinds of different kinds. So the point is that we have mathematical techniques and mathematical skills, and we apply them to a huge range of systems, from the smallest scales, accessible, particle physics, to the very largest scales, cosmology, the scale of the whole universe. This little movie here shows a superfluid fountain, and this is actually very, very cold liquid helium, which when it's cold enough, exhibits a quantum phenomenon called superfluidity. And that basically means that the fluid flows with no viscosity, zero viscosity, and that means that you get this beautifully smooth fountain which appears to last forever, and it's basically tiny amount of heat put into the fluid at the bottom of this picture that makes it form this fountain. So that's a nice little experiment. The theory behind this involves a version of the Schrödinger equation. That rather scary looking piece of mathematics at the top there is called the Gross-Pitievsky equation, and it's an equation which is used to describe superfluid behavior. Incidentally, another thought experiment you could do with superfluid is that if you had a cup of superfluid and you stirred it like you would with a cup of tea, with a cup of tea, the circulation of the tea actually gradually dies down, and you end up with a stationary fluid inside. With a superfluid, there'd be no friction between the fluid and the side of the cup, and it would just carry on spinning forever. So that's a very distinctive property of a superfluid. Now, those things sound rather kind of abstract and highfalutin, but it is worth thinking about what things that you could do, as a career with a degree in theoretical physics. From the TP&M course, it's actually about half of the students will actually go on to do further degrees, so a master's or PhD, and so that's what you might call academic research. And this course will prepare you very well for that. Among the other career opportunities, there are really many of them. There's teaching, of course, but there's also anything that involves computer, mathematical modeling, computational modeling, numerical work, information technology, nanotechnology, aerospace, bioscience, all kinds of different things, including financial services and other things in the commercial and industrial sector. The point about theoretical physics is that you learn a battery of different techniques, mathematical and numerical, and those can be, of course, applied to physical processes, but also the same mathematics can be applied everywhere. You learn a great deal of problem-solving skill, which is sort of universally required throughout the world of jobs and employment. So here's just a few of the things that you study as part of TP&M. The first year of it is actually pretty much fixed in terms of what subjects you do. So to begin with, you do thermodynamics and statistical physics, some mathematical techniques in physics like vector calculus. You also do quantum mechanics and special relativity, computational physics. As you move on through the program, you'll find that there are more optional courses, and so you can specialize in whatever you're interested in. And I've just listed a few of those on the right-hand side of this slide. So astrophysics and cosmology, particle physics, quantum information processing is something which is a very hot area these days. General relativity, fluid mechanics, and superconductivity. Those are just a few of the options. Of course, you also will have the chance to do computational work and project work in computations as well if you want to. Now, that's just the theoretical physics part. It seems a lot, but it's only half of the program. And in TP&M, you will actually have a complementary program of pure mathematics, which helps hone your mathematical skills for the so you get a good blend of mathematical and theoretical physics ideas by the time you've graduated. Over the past few years, we've typically required something like 500 CAO points for this. You must have a higher mathematics as well. Also, one laboratory science subject. You don't need to have done chemistry. You don't need to have done physics before joining this. It doesn't do you any harm if you have, but we don't require it. Okay, and those are the requirements. Now, if you're slightly worried about the high CAO points for MH206 rather, I just mentioned that this is something which we have only recently done, which is that you can actually do TP&M through the general science program MH201. Now, what we require for that is the students would enter into MH201, do mathematical physics and mathematics, of course, in the first year. If you do well enough in those subjects, you can transfer into what would be the first year of the TP&M course. So that would be a 4-year course, but the 3 years after the first year are identical to MH206. And we actually get quite a few students nowadays transferring from that, having proved that they can do the maths and the physics in the first year, transferring into a joint honours programme in year 2 and carrying on and ending up with a degree in theoretical physics and maths. So if you're interested in that possibility, I suggest you look at the presentation for MH201, Mathematical Physics. Well, that's all from me. I hope that's been reasonably informative. I just wanted to say that if you have any questions during the open day itself, please contact me, because I'll be standing by waiting for them. But at any other time, if you have any questions about the theoretical physics and mathematics course, then please feel free to ask as well. You can drop me an email at the address given below. Thank you.